Hello and welcome back.
Hi everyone.
All right, Andreas is here with me, and today, what am I going to learn from you today?
Today again, Quarkus as always. We want to talk about fault tolerance, meaning what can we do to mitigate faults that can happen. I mean, maybe you make a REST call to another service and it fails. So you need to think about what you're gonna do in that case. Are you failing your client, or are you maybe retrying it? Maybe it works the next time because just that one pod had an error or so. Or are you using a fallback mechanism? So using like a default answer. Also, what are you going to do if you have overloaded a system with a lot of delay? Maybe you shouldn't let your client wait forever. Maybe you should again abort and give him like a fallback answer or so to keep your system responsive.
Okay.
So that's what we're going to talk about today. And with that, I think
What's the first part?
first part will be about retries. But actually, I'm first going to show you a bit our framework.
All right.
I prepared a bit. So just to set the stage, we have our cookie resource where we can get cookies. And here we just bake a cookie with the cookie service.
Big cookie.
Yeah. And the problem is this is a very unreliable cookie service. So for once, in 20% of the cases, we are out of ingredients. Happens. Another 30% of the cases, we burn the cookies. Too late to pull them out of the oven.
Okay.
And only in the remaining time, we actually get our new cookie.
Okay.
So that should set the stage. And we can have a look at the responses, what we get from the service. So just Postman calling it. So here's your new cookie. Oh, we were lucky the
Can
first
you
time.
increase the font size?
This was...
Yes.
I remembered it in the IDE this time. Okay. So I'm super lucky. I'm out of ingredients.
Okay.
And now it burned. Okay. So you see, in like 50% of the cases or so, we still get a good cookie. But you can easily imagine, like, we have the baker overslept or drank too much yesterday evening, too much Glühwein, and now he's burning even more.
Okay.
So we have a very unreliable service. And it's important to note this can be anything. This can be your REST call that you make to somewhere else. This can be a bad database or something like that. So now with the updated thing, you should get way more burned cookies. And you see now it's quite tedious as a client.
Yeah. Really bad.
Yeah, really
No cookies
bad.
for you.
Yeah, no cookies for me.
Oh, wow. Okay.
So this might happen, that it must not be a thing that is all the time happening, but maybe the service you call has a bad day. Yeah, I mean, they made some errors, or they are overloaded or so, something like that. A lot of things can happen in the real world in production. So you want to mitigate that.
Okay.
One thing we can do, we could retry. So we can just add this retry annotation. We get this retry annotation when we add this dependency. Quarkus SmallRye fault tolerance. This is an implementation of the microprofile fault tolerance spec for Quarkus. And as always, there's a nice guide, the SmallRye fault tolerance guide, which explains you everything. as always, with an example project starting from which dependency you need and so on. So when you have added this dependency, then we have the add retry annotation. You can have a look into that. There's a couple of config parameters that we can specify. For starters, we have the max retries. So by default, it retries at most 3 times. After that, it finally fails. So you can increase that or decrease that or just keep it. There's also a delay. So often when it failed at the moment, then it makes no sense to directly retry it. Maybe you should wait a second or so.
Okay, but this is on the backend side. So normally I would have the retry on the client side.
Yeah, but I'm also client of some other services in the backend.
Yeah, but now you're using it on your backend side.
Yeah.
So, and normally if you do the retry logic, you would implement it on the client side or whoever is calling it. But now you're doing on the other side.
Yeah, I can use it everywhere.
Okay.
In my service, but it would be especially good for when I make a REST call, for example, because when I make a REST call, that might fail, or when I gRPC call, anything that I interact with another service, because that other service could fail. I usually would not use it inside my service. This is just a example, but you can. You're free to use this on any method of any bean. You can also specify it up here for the whole class. Then every method in this bean will have this applied. So this is a quite powerful tool.
Okay. So what does it actually do?
It retries.
So when I call this function from my client, then I don't have to handle the retry. It will retry it for 3 times.
Yeah.
And if in those 3 times there's no non-error message, it will return the error message.
Yeah.
Nice.
So let's just try this.
Okay.
I mean, probably from the client or also from other implementations, you know, when you try to implement a retry, it's tedious. And it's also not so easy to really make it good. And a lot of things you have to take care of. This does all of that for you. So here's my new cookie. How lucky have we been? So we tried to bake a cookie, but it burned.
Okay.
And then we tried again. And then it worked.
Huh. I like it.
We can do this again. Now we tried to bake it, it burned. Then we had no ingredients left, and then we tried again, and it worked.
Okay.
So that's
really nice. This is really nice. Okay.
And that's all you need to do.
The retry will actually re-execute the function.
Yeah.
And then we'll wait for non-error part.
Yeah.
Okay.
And you can also specify for what it should retry and when it should abort. Because there might be errors. I mean, you call it a REST API. There might be a 404 not found.
Okay.
Because what you try to get is actually not found. That is not something you should retry.
True, yeah.
It's an expected error. In our case, we could say, okay, if we are out of ingredients, it makes no sense to retry. So there's abort on. And we can just specify the class of the exception that we want to, in that case, we want to abort. There's also retry on. This is also a list which would specify, basically, this is blacklisting of exceptions when it should not apply, and this is whitelisting of exceptions when it should apply.
Okay.
So depending on your use case, you can do that. So now when we do it again, it has to rebuild. Burned, all burned. no ingredients left. Okay, was the last one, and we are out of ingredients. And you see, we tried it once, twice,
Was burned.
once, twice, and the third time we ended with that. So we would have ended anyways. Out of ingredients. Yeah. So first time, and we had no ingredients left, and we did not retry.
Okay.
So that's what you can do there. Also, you can specify, like I said, you might want to wait for a second until you retry. You can also specify the unit here, like if you rather want to write it like that.
Okay.
That's just a nice thing that there's this, but by default it's like milliseconds. So in that case, we'll retry it now. First we have to build again. Okay. So you see now the call takes longer.
Takes a lot longer.
Yeah. Maybe if I show you the logs directly, I do the call again. Okay, worked first time. Now you see there's this delay in between. And
wait, I will turn off my camera. Let's hope it's this one. Yes. So now there you can see it, right? Yeah.
I mean, the important part is like this here.
Yeah.
So Moritz, you can stay.
Well, you don't have the timings. The timings are behind me. So now you will see, okay, it's
1 second
you see
here.
0 second, 1 second, 2 seconds, 3 seconds. So, okay. Yeah, got it. Nice.
And there's even more. So for such retries, now we have a constant retry, but it could also make sense to increase the time until you retry. So for example, when you sometimes you have exponential backoff strategies, where you exponentially increase the time when you retry. This helps to spread out the calls a bit more.
Okay. So the first retry would be after 1 second. The next retry would be after 5 seconds, 10 seconds,
2,
and whatever. Yeah.
After 4, 8, 16. So we could do like max retries 6 or so that we can see a bit more, and then it's exponential backoff. This also has some properties like the factor. This always doubles it. There's also max delay, so it will not wait more than 60 seconds.
Okay.
Between each retry. So if we try that again, you can now see it's getting longer and longer until we retry.
Okay, I have to turn off my camera again.
Yeah. So
okay, so we have
initially
0,
we have
then
1 second,
okay.
2, 4, and then 8. Yeah. And now we are waiting for 16 seconds. So this will take longer and longer and longer.
Okay.
Yeah.
This is pretty cool. Because I only thought that the client can do this and not the backend part.
Yeah, you always have to consider that in the backend, when we call another service, we are clients.
You also need to say, yeah.
We are we are in the middle.
Right,
we are
yeah,
both.
yeah.
We are backend and we are clients.
Yeah, but still, this endpoint might be something that the client will actually contact.
Yeah, I mean.
But you can also configure it that it would be possible to have all the logic from the client, basically, all the retry logic. So you can filter it out that you say, okay, only if this really doesn't do anything and there's an error I can't fix, then I will get the error back. But otherwise, I will keep trying. So that's pretty nice.
Yeah, I mean, you still might need a retry logic in the client because you could have connection drops in between.
Yes, of course, yeah.
But we, as a backend, we should always try to provide the best service possible for the client. And this is just a tool that helps enormously with that. And you get it basically for free. I mean, this costs nothing.
Yeah. But basically, this would be something that you wouldn't do it in a normal backend. You would more likely do it in a BFF kind of scenario.
In a BFF, it's especially important because you're mainly just calling other services and aggregating stuff. But also in the normal backend, you have like database where you might be able to have a fallback or retry it because the database connection might be bad or so. And we will come to other annotations. So you can do a lot of stuff with that and handle failures gracefully and in a nice and concise way that is easy to maintain and to understand. I mean, when I read this, I know what's going on.
Yeah,
I do
that's pretty cool.
6 retries at most with a delay of 1 second. When this happens, I abort and I have an exponential backoff strategy for the retries. So, and no code and maintained by ourselves that we have to maintain and make sure it really works. You just add this annotation.
Nice. So now the question is, how often have you used this in a project actually?
I've seen a lot of projects where it should have been used, but it was not Quarkus, so it wasn't easy to use it like that.
Okay.
In Quarkus projects, I haven't used it too often, the retry thing, because there we didn't have the bad other services that continuously require that. But from some customer projects, I know I have some candidates in mind where it directly would put this.
Okay, so you wouldn't put it in just as a precaution. You would only use it if you really can use it, and not just for fallback, default fallback. If there's anything wrong, then just do this.
Yeah, I mean, you also need to consider what this implies. You will, if another service fails, this might cause it to be called 6 times for every single time you get called. So it's like a DOS attack. So you scale up the errors. So you need to consider this and to make sure you don't kill the other service even more. But that's, for example, why we have the exponential backoff or so, and should add the delay so we don't like DDoS it. And also like this, you really have to consider this. When do you really want to retry? As I said, when I make a REST call and I get a 404, where it can happen, get user by ID or so, and the ID does not exist, then I will get a 404. There's no need to retry. So,
yeah, right. Yeah.
You still need to think about when you use this and if it makes sense. But if it makes sense for you, it's easy.
Okay. Okay, so one thing we have to do is, I guess you have to check for your mic because mine is already pretty close to my face. Yours might have to move a little bit up to your face. Hopefully it's possible because we still have some cable.
I moved it a bit up.
Yeah, hopefully this will help it. Okay, so what did we learn?
You can use SmallRye fault tolerance in Quarkus. You can just add this extension, and then you have a lot of different annotations that can help you make your service more reliable. And at the moment we had a look at the retry annotation, where we can specify how exactly we want to have it retry, and you can put it on any method in your Quarkus service and have fun that it just retries and you don't have to do anything for it.
Nice. Yes, very cool. So
maybe any questions in the chat so far? So while we're waiting for chat, where's on your mic, Moritz?
What? Am I too loud?
Okay, maybe turn this up a bit down.
I can turn it down a little bit. Hopefully it's better. Okay. How about now? Is it better?
Maybe also turn.
We call it debug in production, right?
Maybe also turn me down a bit, just to be sure.
You're not in the
yellow?
red though, yeah. Maybe.
That can be.
Yeah.
Hopefully it's better now.
Yeah, we could have a wall between us, so I can actually see through the camera and see, yeah, right there. That's, yeah, I think my voice is too loud and his microphone will already
Pick it up also.
will pick it up, yeah.
Ooh.
Yeah, there's a delay, yeah.
Yeah, we added some retries on the delay.
So let's see. Okay, I will turn both of them down just a little bit more, and hopefully this will help the audio issue.
Hopefully.
And since we already talked all the time and we got yelled at this morning, or I did, for not shutting up for a few seconds, we will keep quiet now.
Okay.
All right.
So
next part.
Let's continue looking into SmallRye fault tolerance. As we already discussed, this is a really helpful tool to make your service more reliable. And let's now have a look at the fallback annotation.
Okay.
So yeah, we have our unreliable cookie service. We added now some retries, so this makes it much better. Let's cut down a bit on these here, just for the sake of demonstration. Still, we might have the issue that when we have a very unreliable service, that we run out of fallbacks. So I'm calling this now again. Oh, now it worked. I'm too lucky. Okay.
Okay.
Just to show the result, we are out of ingredients. We already saw it here in the log.
Yeah. Wait. Maybe you want to shortly go back to the bake cookie part. For those who just started.
Okay.
Just to.
Yeah. So we have our bake cookie implementation here, which is a bit unreliable because in 20% of the cases we might run out of ingredients, and in 80% of the cases we burn the cookies. We have a very unreliable cook at the moment, or baker. And if all goes well, we return the new cookie. And to improve the situation a bit, we added a retry. We now retried 3 times with a delay of a second. But we only do this in the case the cookies are burned, because if we have no ingredients left, then yeah, no need to retry. We have no ingredients left, so that's why we exclude this this exception here. Now, in the case the baking of cookies fails, we still want to do something for our customer. So we can add a fallback. It's another one of the SmallRye fault tolerance annotations. You can just add this fallback method. And then there is it's fallback annotation, and then you specify a fallback method. Here you have to specify the name as a string, which is a bit not so nice, but it's based on how annotations work. Let's call it bake cookie fallback. Very creative name. At least it's speaking. And we have this method here.
Fun with bake cookie fallback.
Yeah. It's always fun with Kotlin. And in that case, we maybe here is an old cookie. So if we fail to bake a new cookie, then we just get an old cookie from storage and hand you the old cookie.
Okay.
I mean, it's better than no cookie. So
or a burnt cookie.
Yeah, or a burnt cookie. So so that's what we will do now. And I will just let me add a logging here. So cookie. And I will call this. And let's see how lucky we are. So again, it has to first go through the retries. Yeah, first rebuild because I changed the code again, but then it goes through the retries, and the rebuild once. Okay, yeah, the first try, and then 3 times retrying it. So actually, it does it 4 times, and we still burned the last one, so we are falling back to the old cookie, and here's an old cookie.
Okay. Which takes a lot longer. But, yeah.
Yeah, I mean, it takes until we give up. It takes time. Because we retry with a second of delay. And I mean, now you could say, okay, let's reduce the delay, which has the risk that you DDoS the other service, but it goes quicker. And it also has the risk that the situation might not have improved in that time. The longer you wait, the more chance you have that the other service has recovered.
Okay.
Or maybe it crashed and needs a bit of time to reboot. If we have this 1 second delay, then you have like 4 seconds for it to reboot, which should actually be enough.
Okay.
Yeah. So that's the retry annotation.
Okay, but basically this would this fallback. Yeah. So basically this chapter would only be the fallback.
Yeah.
So you don't have retries. So this means if you go into the first one, which means no ingredients, you get an old cookie back.
Yeah.
And if you get into the second one, where you burned it, you will also get an old cookie back.
Yeah.
And if you get all the way to the end, so you would get a new cookie and you wouldn't hit the fallback, right?
Yes.
Okay.
Let's increase our chances. Here's a new cookie.
Nice.
Here's an old cookie. New cookie. New cookie. Huh? Old cookie. But if we would not have the retry at all, I mean, you can also do that. Just get rid of that. Then we get the old cookie way more often because we just don't have the retry.
Yeah.
And again, you can do this basically everywhere. You could also do it here on the resource and then return a default response or so.
Okay.
You can do it way down the line in some internal service and return a useful fallback. For example, if you have like a recommendation system. And maybe it's just down at the moment, but then you could hard configure some default recommendations, like the most sold products or so.
Okay.
I mean, it's better than showing an error or showing nothing.
Right, yeah.
So you could say, hey, if it really doesn't work, just return the default recommendations. And again, it depends on your use case. One thing I want to add is there's not only this fallback method, there's actually also a fallback class that you can specify. And this class needs to implement this fallback handler interface. And there you get this execution context, which contains method, parameters, and the failure, so the exception. And then you could even, based on which type of exception you had, you could return a different fallback or so.
Okay.
Yeah. So yeah, this is more flexible and also better typed. But for the quick and dirty solution, this also works. And I mean, if you have an IDE like IntelliJ, you can still rename, and it doesn't work. Yeah, normally you can. But that's the risk. However, we have Quarkus. So this is, although this is just a string here, it's not like this is reflection that is running during runtime. This is actually connected together during compile time. So now we have, or during startup, it notices this already because it connects it all together and notice that this one here is not connected. Yeah, so on the bake cookie, we can't find a fallback method.
Oh, okay.
So you have a check there.
Nice.
Okay. I think that's it about the fallback.
Okay. Let's recap.
Yeah. Fallback is a nice annotation where you can implement a fallback. If your method fails, you can do it after you retry it a couple of times or in any other failure. Just provide a default response that could handle things more gracefully instead of throwing an arrow. Yeah, and that can be really helpful.
Nice. I wasn't looking, but is the status, the HTTP status code for the response also changing, or is it just as a normal, all done, all good response when you do the fallback?
It's then an all good response.
Okay.
At least in the how we used it, because we just from our service returned a response, and our response object was only a string. So the string got returned and the caller got a string. So for him, it's all fine.
Yeah, but normally you would do the same thing, right?
Yeah.
So fallback is actually an acceptable answer in a successful state, but you couldn't get it. That's why it's a fallback.
Yeah.
Okay.
But you could also, when you use it, for example, on the REST method, on the resource method, then you could also return a different response and set a different status code on the response. Maybe you have talked with your client and told them, hey, in case it's a fallback, they want to show a bit of a different UI with some different content, then you could send them a different status code or so.
Ah, interesting. Okay. Nice.
So you're flexible there, but if you do it like super down the line in a service, then you probably, you would need to extend your response object to include that information. But again, like you said, a fallback should be an answer that is also good. It might not be the best answer, but at least a good one.
Yeah, who wants an old cookie?
Better than no cookie.
Right. So maybe we have some more questions from the chat, not about the microphone setting. So.
The second quiet Moritz is still audible. Yeah, we really need to check our mic setup.
Yeah, I turned it down all the way now, so I'm not sure.
Yeah, I think the also that
not a question for the topic, but an old cookie is still better than an already eaten cookie.
Yeah. True. I fully go with that.
Okay.
Yeah. So if there are no questions, we can check out the next SmallRye fault tolerance annotation. And this time we will have a look at the timeout annotation. And as the name says, you can make a timeout with it. And this can be really helpful if you have like an endpoint or a method that you need to call that you need to get a response in time from it, or otherwise it's worthless, or you don't want to let your client wait forever. So you might rather abort the request.
Okay.
And maybe go with a fallback.
So you would expect an answer in a certain time frame.
Yeah.
And if you don't get it, then the answer won't be. So you can just cut it off and tell, okay, went into a timeout.
Yeah. Nice. Or maybe if we again think of a recommendation system. The client asks me for a recommendation, maybe for a search phrase of the user. If I cannot deliver you that in a second, or I would say in a half a second, then it's probably worthless anyway. Because the client, the user typed something else, or he wanted to click somewhere else, or he's annoyed already that it's taking so long. So in that case, we might want to fall back again to a default recommendation.
Okay.
And maybe retry the call later again. This can also help if you make this timeout that you reduce the load for the other system, because we in that case we don't retry forever or so, but we just say, okay, you can't manage in a certain time frame, then that's okay. We can live with that.
Okay. Then let's jump into it.
Yeah. Again, we want to have a look at our cookie example. And this time...
So let's explain it again.
Yeah. We have our cookie resource, our awesome cookie service where we can get freshly baked cookies. But this cookie baking process is a bit unreliable. We might have the problem that we don't have any ingredients left. And we might have the problem that we forget about the cookies and don't pull them out of the oven in time, and then they are burned. So because today we are very unreliable in our timings, we added a retry. So we try 3 times. If ingredients are out, okay, we don't have to retry. There's nothing more we can do. But if we still fail after 3 times, we can also use the Fallback Annotation, which is another SmallRye not reactive messaging. That's a different package. It's SmallRye fault tolerance annotation. So what we want to do now is this can take some time. Let's say we retry 3 times for a second, but we are a bit, we don't want to wait that long. We say our client at most waits like 1500 milliseconds. So this is again just an annotation. We put it here. And if it takes longer than 1500 milliseconds, then we abort. And if we test this, just start up the service. It has to be said, in our case, this makes not too much sense because we retry here and abort on the other side already. So in that case, it doesn't make so much sense, but you can imagine you just call some REST API and then this REST API takes a long time to respond. So we have started our service and we call it, and there's a new cookie. So we were lucky. We got a new cookie. Here's an old cookie, ran into the fallback. And now we get a super ugly exception.
Super ugly.
Yeah, we didn't add a exception mapper for that. So that's why we get the full exception. But what we see here, we got the timeout exception. So this is just a fault tolerance exception. And yeah, so we tried to bake a cookie. It burned. Then after a second, we retried that. It burned again. So we would wait again for another second.
Yeah, let me see what's the timing. Okay.
Yeah. Here.
Yeah.
Yeah. So it's just swapped over to the next second. So, and now we would try again after the next second, but during that time, after 1.5 or a half second later, we abort. It's done. There's nothing we can do. We need to return to the client and tell the client something. We can tell the client it failed. We should throw a better error than 500 probably. But it would also be reasonable maybe to tell the client, okay, I cannot serve you at the moment. It's too much for me. Let's ask me another time. But what we again can do is add like a fallback. Get cookie fallback. It doesn't have to be named like that. It's just that I'm creative with names. Here we return again a string. Yeah, we go to the get cookie fallback, and maybe we here is your money back. So maybe we return that, or we return some default recommendations or something like that. Yeah. Again, we could also specify here in which case we want to do that. So, for example, in the no ingredients left case, we might want to give the client the idea, okay, there's no ingredients left. But in the case of a timeout exception, then we actually want to go there. Timeout. So, okay.
Whoa, wait. Okay, you have a fallback and you skip on timeout exception. Okay,
Yeah.
so
no, sorry.
you don't want to skip on, right?
Yeah, I want to apply.
Oh, okay. Now I
Yeah.
get it. Okay.
Yeah, I want to whitelist this exception. Thanks.
You're welcome. Just thought there was an error on my side, but okay, get it.
Just testing my moderator if he's paying attention.
Yeah, I had to do some moderator stuff, but I'm back now and I'm paying attention. I see you.
Yeah, that's nice.
Okay.
So let's try again. New cookie worked and an old cookie worked. Come on, I cannot be that lucky.
So now, wait, I think. Oh, okay, yeah.
Yeah, it's, the chance.
Yeah, the timeout won't hit. That's the
Yeah,
problem. Okay.
timeout won't hit
Yeah,
because
okay.
I don't retry often enough.
Yeah.
Because I was just too lucky.
But actually, you have a delay of 1 second.
Yeah, on the retry. So
And-
one retry would work.
Okay, so it always went through on the first thing. Oh, okay, gotcha.
On the first thing or on the retry. So it had two chances.
Okay, gotcha.
Timeout. Here's your money back. So we can have a look again. So we tried to bake a cookie, it burned. We tried again, it burned.
Again,
And then we aborted because
automatically.
of the
Okay,
timing.
let's see at the timing again without my face in it.
Yeah, again
it
on
started-
the second switch.
Okay.
So this is almost a 13. Then we have at 14 the retry.
It's almost a second afterwards, and then you have a second and 14.
half a second
okay, yeah.
later.
And there you fall into the fallback. Okay.
Yeah. One important note: these retry, they also added jitter by default.
Jitter.
Jitter.
What? Okay.
So it's not applying a second by default, but it's
Okay.
applying a second plus minus 200 milliseconds with random plus minus 200 milliseconds.
Okay.
This is again to mitigate like a coordinated attack by accident, because you spread out your calls. So maybe
okay.
in 1/2 of a second the service was not reacting, and everybody that was calling in that half a second will call now in a second again, in exactly the same second again. So you would have a real bad load peak again, and then the next second afterwards again.
Clever.
So this makes it that you don't call it in exactly a second, but in a range from
Roundabout.
800 to 1200.
Nice.
So it spreads it out, and then because afterwards you would again delay it with a different delay, so it spreads it out even more, and you get a wider but flatter curve over time, or with the amount of retries.
Nice.
So this helps to mitigate.
Just because jitter could be reducing the time or extending the time.
Yeah, it's plus
so
minus.
I already saw that you can just as an experiment, you can already define the unit. So if you set a bigger unit in the jitters than you have in the delay, then it would actually not, like, it couldn't go into the future, right? Couldn't send you an answer before you send the request. So,
negative effective delays will be 0.
Okay.
So then it will just retry it immediately.
Okay.
Yeah.
Nice.
But of course,
that's
it
very
makes
cool.
more sense to have a smaller jitter than you have a delay.
Mm-hmm.
But this again, it's configured by default to sensible value, and it just helps to mitigate this concentrated attack that you might create by accident.
Nice. Yeah, so I'm seeing a lot of things I want to implement on my backend, but I'm of course not using Quarkus.
That's
Not
maybe
yet.
a mistake.
I tried. I know. Maybe the third time I will write it, or the fourth time I will write it, I will actually use Quarkus. But for now, I'm sticking with the language I know at best. So, but this is nice.
Yeah, and it's basically for free. All you have to do is you go to your Gradle or Maven dependencies, and you add this Quarkus SmallRye fault tolerance, and it works.
Nice.
Yeah.
Yeah, that's actually pretty cool.
Yeah, it's really powerful.
So how often have you used this?
It's same with the retry. I have some, at the moment I have some customer projects where I would use it, but it's different technology. It's Node.js.
Okay.
And I miss it really there. Especially this nice declarative way of just adding stuff like that. It's telling you what's happening, and you read it, you know about it, and it's not like promise stuff where you can also add a timeout or so. But it's just for free. It's integrated. It's working. Yeah.
Nice. Very, very cool. Very cool. Okay, let's recap.
Yeah. So we just had a look at the timeout exception, or not timeout exception, timeout annotation of the SmallRye React fault tolerance package. And it just adds a timeout to your method. You can specify it, and if that timeout runs out, then you get a timeout exception. And what you can then do is either handle it with a try catch in the caller side, or you can add a fallback and fall back to a reasonable value. And that can help you to make your API very responsive and give guarantees when it will answer. This might be very interesting for some certain use cases in your clients.
Yeah. Yes, very cool, very cool. So, before we do we have another topic?
Yeah, we would have another one.
Okay, so before we change the topics again, are there any questions from the chat? No, and no big offers either. That's funny. It looks like. Yeah.
Second to.
Looks like I did everything right. The UI has changed for some reason, but.
The UI has changed?
Yeah.
Ah, okay.
On the
on Twitch.
On Twitch, yeah.
Yeah, that's.
But got it. Got you. Jokofaptel. Or whatever the name was. Okay.
Yeah. We can have maybe we make one more thing and then we continue next time. Because there's actually 3 more things I would like to show.
Ooh.
And I think that's...
Are you in a hurry?
Yeah, today I actually have to leave.
All right, okay. So let's get started.
Not a hurry yet, but it won't be enough time to make all of them.
Okay, last part for today.
Yeah. Let's now have a look at SmallRye fault tolerance package at the how we can use it with Kotlin Coroutines.
Ooh.
Yeah.
Okay.
Because this just works out of the box.
Nice.
So.
Okay.
Let's have a look again at our cookie resource.
Yeah. Do you want to clean something up beforehand? Or do we need them all?
We don't need them all, but we can still have them all.
Of course, but still.
Yeah,
okay,
let's get rid of
yeah, let's get also. Let's say what the cookie service bake cookie actually does.
So we have our cookie resource where we can just call the endpoint and get back a cookie. This is our cookie service. And the bake cookie function, it tries to bake a cookie, but it's a bit unreliable. We have a 20% chance that our ingredients run out, and we have a 80% chance that the cookies are burned. And only if that doesn't happen, we get back some cookies. So what we did, we added a retry and another annotation from fault tolerance. So we tried 3 times with a delay of a second, but only if it's not an out of ingredient exception, because if we don't have any ingredients anymore, we don't need to retry. And if all of that doesn't help, we still have no cookie left, then we make a fallback to the bake cookie fallback and we get an old cookie.
Okay, sounds good.
So now we have this and we want to use Kotlin Coroutines. As you might know, Quarkus in certain extensions, it already supports Kotlin Coroutines. Unfortunately, it's not the big amount of of extensions. We still try to push them, but Red Hat, yeah, they're a Java company coming from the Java world and only slowly getting on their Kotlin train.
Choo-choo.
Yeah, but for this endpoint, we use Quarkus REST Easy reactive messaging, REST Easy reactive, not messaging. I don't know why I have messaging in my head today. Yeah, so when you use this REST Easy reactive, then you can directly use suspend functions as your resource functions, and this then expects to be non-blocking and runs on the event loop directly. So this is super fast. And
where would it run without the suspend?
Without a suspend, it would run in a thread pool.
Ah, okay.
Yeah. So in Quarkus, Quarkus tries to identify what your method is doing or how it's behaving, and it's doing that based on the return type. So if you have such a return type, which is not, so you could have a uni, which is basically Quarkus kind of promise. And if you return a uni, then it knows, okay, this is asynchronous code. You have this method chaining with like with promises then and error. So, but then you would need to write it like uni create from item something, and then you could on item transform it to blah. Something like that. And also like on error, on failure. Yeah, you could also do something. So this is like this reactive programming style.
Okay.
Where you can do non-blocking programming. But this is, as you've seen, this is really unreadable. I don't like it because it's just, it hides the intention of the code behind a lot of boilerplate. But if Quarkus detects this, then it expects it's a non-blocking method. So everything that is blocking that you want to do in there, blocking the thread, like a thread sleep or calling IO, you would need to do on a thread pool. And there's mechanisms for it to say like, okay, now run this part on a thread pool. But you must never block the execution in the uni, because then you would block the event loop of Quarkus. And then it cannot receive any more requests, at least if all event loops are blocked, because Quarkus has multiple event loops. So, but if you have this, it expects, okay, there might be blocking code because this is like the standard Java enterprise coding model from since ever. And there it was always done with blocking. And so you can just use that and do blocking stuff in here. So thread.sleep it's not recommended because it's still stupid
Okay.
to do that.
Yeah.
But you can do it, and it won't kill Quarkus or
Nice. Okay.
block it. But you can also use like suspend functions. And then again, it's expected that you're doing non-blocking stuff.
Okay.
And if you, like our method here is not blocking, then you could also explicitly say non-blocking. This would now prevent this method to, so it would make that this method is run on the event loop and not be run on a thread pool. That saves you the thread switch.
Yeah. So it would actually be the same as suspend?
Yeah.
Okay.
But suspend brings us to the Kotlin suspend function world. And now we can also call other suspend functions like this here. And maybe the cooking or baking process, or before we even decide, this takes a bit of time, like 2 seconds or so. Now this is also a Kotlin delay. So this will not block the thread. You see here, this is a suspend function itself.
Okay.
And you can also only call it in a suspend function. Now it would not work because we are no suspend function.
Okay, I didn't see that you removed the suspend.
sorry.
You were a little bit too fast. Okay.
Yeah.
So if you have a suspend function, then you can of course call delay because it's suspended. If you don't have it, then of course you can't use it because it's not supposed to be stopped anywhere.
Yeah.
Okay.
Exactly.
Got it.
And if I want to do a delay, then I would either have to use something in Uni, which does basically the same as delay, not block, but also delay it.
And boilerplate?
Or you would need to use thread sleep, but that would really sleep that thread.
Yeah.
And if you get 1,000 calls per second, you don't want to sleep for 2 seconds, all your threads. So delay just pauses this execution for 2 seconds, but not the thread.
Okay.
And the cool thing is, all of that still works. All of the retry fallback stuff, it just works with the suspend function. So one thing I noticed is you need to restart usually.
You removed the timeout we had before because this would now then be problematic, right?
Yeah, with the 2 seconds here, that would be problematic. I only added this basically to show the suspend function. You can also use suspend functions for the REST client in Quarkus. So if you only call other functions, then this is fine.
Okay.
What did I?
You broke it. Fallback. Coroutine can't find fallback.
One important thing, if you add a fallback, then the fallback method must have exactly the same signature. So it also needs to be a suspend function. There's not a requirement from Kotlin, so you can also call non-suspending functions from a suspend function. But
as a fallback, you
the way Quarkus matches that, how it matches to that method, it just checks it's the same way of working. So it
even though the logic isn't different.
Yeah.
Okay.
So that's just how it's implemented in Quarkus. And it makes sense, for example, for the uni stuff, you still need to get a uni. And it's no big thing.
But that actually wasn't the mistake it showed us, right?
It was that we didn't have this here.
Yeah, you didn't. It told you didn't have the function, but didn't tell you that it had to be suspended, right?
Let's check again.
I said it was the naming was incorrect. Let me get rid of my face in here because then you can read it a little better.
Fault tolerance definition exception. Invalid fallback.
Can't find.
And a cookie continuation. So this.
Okay, Kotlin Coroutines. Okay.
Yeah, can find fallback with same parameters as the method.
Okay.
Yeah, so it
It's
says
a little-
parameters, but at least here
Yeah, if you
they say this, so you have a kind of a hint.
Okay, yeah. So if you see the coroutine, you know, okay, there's something with suspend on it,
Yeah.
but actually from the message itself, it doesn't, because the parameters are something different than.
Yeah.
Okay, but okay, nice.
Okay. So now we can start this, and this works just the same way.
So maybe I have to get rid of my nice face again to see the timings, I guess.
Yeah, let's make a call. What do we get this time? A new cookie.
A new cookie. Okay, so what happened?
So okay, we have this delay now. Let's remove that so it doesn't take too long. Of course, first rebuilding, trying to bake a cookie, no ingredients left, falling back to old cookie.
Okay, yeah.
Yeah.
So that's a old cookie. Okay.
Another time. Yeah, so we retried a couple of times, and in the end it worked. And that's a nice thing. It just works with this coroutines here.
Mm-hmm.
And like you can use it here in the REST endpoint, you can also use it in a REST client suspend function. So if you only have like, you expose an API for your client and you only make calls to another REST APIs, you can make everything suspending and super fast.
I thought it always has to be suspending if you're working on the client side, on the server side.
No, it's just a Kotlin way of making async await.
Okay.
So
some,
but you don't have to.
You don't have to do it.
Yeah, that's the nice thing about Quarkus. I can make this method here, suspend. I can have this method here, blocking. And so now I have, of course, I need
So
a different
when-
path, but
Okay. Was just gonna say
Yeah, so-
when is which one gonna be called? Okay, so you have cookies and cookies ABC.
or blocking. Yeah.
Okay.
So
Got it.
in Quarkus, you can mix reactive programming, suspend functions, unis, and blocking. You can mix it and use whatever you need for whichever endpoint you have.
Nice.
You
Very
can mix
cool.
it everywhere. This is really flexible, so you can use it where all the things that fit you best in the situation.
Okay.
Okay?
Nice. Very cool.
Yeah. So maybe a short recap.
Yes. Last one for today.
Yeah. What we saw is we had a look at SmallRye fault tolerance for Quarkus, and in there you can just use also suspend functions and apply like retry, fallback, and other annotations. Yeah. And I think that's it for today. If there's any more questions in the stream, the chat, then go ahead. Otherwise, I would say we continue with this in 2 weeks.
Yes.
Maybe with you again.
Next week will be.
Wait, in 2 weeks. 2 weeks is.
No. So okay, let's talk about our future plans on this channel. So this next week I won't be here. I will be attending a seminar and I can't be on stream, but we have a surprise for you, and it's kind of a surprise for us because Timo and Jonas are going to be back with something connected to Swift and iOS, but we're not sure what yet, because there are a few really nice topics we discussed, and I'm pretty sure it's going to be awesome because I know all the topics and they're pretty cool. So this will be on next Friday, as always.
Nice.
What is it? 2:30?
3:30.
3:30. Okay, German time, 3:30. And then this will probably also be the last time for this year on stream, at least on Twitch at least, because the week afterwards is going to be our little Christmas get-together, and then it's going to be one day before Christmas, and nobody's working one day before Christmas. Yeah, so next week's going to be probably a little bit Christmas-themed, some kind of. We'll see. All the topics were awesome, and yes.
Cool.
That's it, and thank you for showing us fault tolerance.
Yeah.
Really, really nice thing, and I think I have to do some work on my end on Vapor and Swift to integrate this, because I'm pretty sure we don't have this yet.
Yeah.
Won't be as nice, I know, but
The Java enterprise world, it exists since 25 years or so. They made their learnings. They built systems that are really crazy. And they experienced every problem you can have. And the good thing is they don't always start over with a new framework, but it's more put into the frameworks. In the past, it has also caused it to be slower in progression. But they picked up speed again with adding new features and stuff. And you feel that it's a mature framework and not just newly born and with all the errors or missing parts. Yeah.
very nice, yes. So with that out of the way, awesome topic today. Thank you, thank for everything. And if we don't see you, then have a very happy Christmas or holidays, and
A nice slide into the new year.
I don't think that works in any other language than German.
The Germans one will understand.
Yeah. Have a great evening, great weekend, and we'll see you on the next one.
Bye, guys.
Ciao.
Ciao.